Good afternoon, everybody, and welcome to the first Scandinavian Rail Optimisation virtual workshop. My name is Ben Holliday, and I'm the Managing Director of Rotea Media, the organisers of today's event. I'd like to start off by thanking each and every one of you for sparing the time to register today. The interest in today's workshop has been very overwhelming, so thank you once again for participating. A special thanks goes to our speakers, Isabel Tardy, Juha Letola, David Deval, Matt Miller, Johan Sundin, and also our moderator, Daniel McGregor. Quite simply, without all of your support, today wouldn't have been possible, so thank you once again. As many of you may know, unfortunately, we had to postpone the physical conference, which was due to take place next month in Stockholm. However, I am pleased to inform you that we actually have a new date now confirmed, which is the 23rd of June next year. The agenda, speakers, topics and theme all remain exactly the same. So please feel free to visit the website scandinavianrail.co.uk to visit the agenda, or alternatively in the handout section on your registration page, you can actually access a PDF document, which is the actual program itself. All it leaves me to say is thank you once again. I hope you enjoyed today's session, and I'd now like to pass you over to Daniel McGregor, our moderator. Thanks very much.
Hello everybody. So Scandinavia is modernising its railways to benefit passengers and support economic growth. A warm welcome to all. For the latest instalment of the rise of IoT and big data in rail, we're very happy that you could join us here today from wherever you are in the world. A big thank you to Ben and to the organising team. Rotea Media's sessions are extremely valuable, and that's upheld by another very well attended session here today. A big thank you to our panel as well for taking the time to prepare and share your thoughts with us. A quick introduction from me. I'm Daniel McGregor, the co-founder of Nexiot. We're a leading enabler for the digital supply chain, and that means that we equip our customers' rail wagons with an IoT gateway and sensors, and we extract that data to the Nexiot Intelligent Cloud platform to provide our clients with all kinds of digital services. When we founded Nexiot back in 2015, the idea of IoT was mainly focused around consumer applications like the connected coffee machine. Many rail customers said, we looked at this topic of IoT and big data already and we decided no. The truth is that the sensors and the solutions were not actually fitting to the customer's needs, but now that's all changed. There's a whole range of hardware solutions available, from sensors to gateways to APIs, and then there's the trickle of data which turns from a stream of data and it's now basically a flood. If you were lucky enough to join our last sessions, then we had a look into the digital rail on both the infrastructure side and also on the asset side. Today we'll be focusing on the theme of digitization in Scandinavia, with a focus on the infrastructure side. Now, more specifically, Scandinavia's digital transformation is now built on speed of innovation. We talk about digitization a lot, but today, let's see what that means for rail in Scandinavia. Now, I want to be careful not to put all of Scandinavia into one basket of huggy and furniture design. There's various regions in Scandinavia, what we call Scandinavia, and the rest of Europe. Obviously, we have the Nordics, and the Finns are slightly different as well. So we have a good representation of all of the areas today on the panel. When we talk about information revolution in rail, we can look at how it affects our approach, but I'd like to focus today on the challenges that are unique to this region. So how can we manage the challenges presented by our unique landscapes, by the unique weather, by customers' industries, and the limitations of our infrastructure or cultural and practical expectations of the people that we support. Maybe we can see some strengths that are unique, or perhaps some legacy topics that help to speed up adoption. I'm sure cultural qualities like being cooperative, egalitarian, and practical help considerably in driving change. Our panel today consists of Isabel Tardy from Bain Nor, Juha Lehtola from Vela, Matt Miller from ISO Soft, Johan Sudin from Traffic Verket, and David Dorval from Stimio. So without further delay, I welcome our first speaker. We're going to learn some more about digitization of rail infrastructure and inspections, particularly in Norway, including new techniques, using big data, using new data sources and big data analysis. So from Bain Nor, the Head of Technology and Regulation, we welcome Miss Isabel Tardy.
Thank you. Thank you for inviting me to this workshop, and thank you for the introduction. Rail infrastructure inspection is what I have chosen as a topic today. Okay, there is some lag here. Quickly, for those of you who don't really know Norway and Norwegian railways, we're up north, but we are a part of the European network, and we share different concerns, similar concerns, particularly in Northern Europe, but in the whole of Europe generally, to improve and modernize our network, and we need innovative solutions to do so. Norway is geographically and climatically a demanding country, and on the upside, it creates an environment for creativity and piloting activities. A very rapid state of affairs of the Norwegian rail network. We have to bear in mind that there are very large distances from north to south, and a few connecting points compared to other networks. As mentioned, the climate and the soil are a bit special. We have lots of mountains, rivers, and lakes that we enjoy, but of course the topology makes it difficult for the infrastructure. In addition, we have high temperature variations. And something that might not be as well known, we have a substructure that can be very hard or with quick clay, and that is also a big challenge. When it comes to traffic load, it's mainly concentrated in the south, around Oslo, the capital, and if there is a delay in this region, then it propagates on the rest of part of the rest of the network. So that is vastly unpopular, and we have to deal with it. We have an infrastructure that is aging, and because of the topology that I mentioned, we have quite a high number of bridges, tunnels, and level crossings that we have to either maintain or renew. Here I have a picture of a new project, and that of course takes several years to achieve. And parallel, we have to have maintenance. That execution of maintenance is going to be outsourced, so we need to have control points, both in dense areas and in sparsely populated areas. So that's the angle I want to focus on today. A quick word about what we mean by innovation in Bane Nor. We have chose the same angle as OECD, that is defining innovation as, quote, values from ideas, unquote, which means that there is a focus on impact, and as much as technologists and people loving technology, it's not just about technology, it's not just about digitalization or even an app, but it's more broadly about developing products, processes, and methods, and we seek to have a positive effect on the cost efficiency primarily, and also capacity of our network, have flexible solutions. So we have a strategy that is represented in this little house, And what we would do as far as optimization is concerned is to optimize according to the 4 missions, which is safety first on top, but also good spending of the money and customer-centric approach. And we aim also to be future-oriented. And further on, we have a number of different initiatives that constitute our portfolio of innovation projects. These projects are focused on value creation, and they are focused on experienced need that are being identified, and how to solve those needs, and how to anchor the good solutions in the organization. We have traditionally focused on improvement in specific technologies and specific competence, but we see also there is a great value in discussing with interdisciplinary teams in order to find a good solution. So in our portfolio, we have collegial assessment and internal funding of application. We have small and large projects, some internal, but quite many as a collaboration with other partners. And you see on the right a little picture of the Norwegian ecosystem with the public sector, and you have also the passenger train operators, you have the freight and logistic operators, and also the research and innovation actors. And we try to gather the different competencies to build on very good projects that gives value. Again, we would like to introduce the results and changes in technical regulations, in new projects, and in maintenance works. So going a little bit in detail, I chose some of the current initiatives, only 3 of them, that are focused on maintenance. Generally, what about inspection that can enhance what is basically being done manually today? We have also a project on vibration and noise measurements, and a third project on video analysis. The first one is that because this maintenance will be outsourced, we need control points, and inspection is critical. As I said, today's inspection is heavily manual. It depends on the person that carries out the work, and sometimes it's non-metrological. So we would like to have a data flow over large distances that can be trusted. The data can be trusted. We have an extended use of different sensors and robots, and have envisaged several solutions. On the right here, you have a picture of one of our solutions that started as a drone, like the upper part of the robot, with a multi-sensored, and evolved to a multimodal platform, being also able to use the tracks instead of just flying. Other project like UIC project Drone for Rail is using only drone solution, and that is very useful in inspection under bridges to look for cracks and so on. But this one is multimodal. Another initiative is on the measuring wagon that we have. It is interesting to carry out noise and vibration measurements, among other types of measurements, of course. And what we have seen is that there is a strong correlation between the condition of the network, the tracks, and the vibration noise profiles. So it's really interesting to actually characterize the noise signature in order to identify not only what we could do to have a more silent network, but also what we could do in order to have a better railhead, for instance, if there is corrugation that is seen on these heads, or some type of misalignment that cause noise. And we can at least identify as soon as possible and correct. And the other advantage that we have with this measuring wagon is that we have sensors on board, and we are able to cover very large distances with much greater precision than when we had static sensors. We just don't have the necessary number of static systems in order to achieve the same kind of results. So now we can begin to have an enhanced strategy for compatibility of wheel and track, and we can also have a strategy for maintenance operations of the track and what we could do in terms of noise. And the third example I wanted to go through is about video analysis. There we have the idea of using video and pictures to different patterns and to different purposes. We have camera-based inspection that can be airborne or on board, which means traveling more frequently. And again, we would like to develop a method for detection and analysis of tracks, what is wrong with the tracks, or what is wrong with the electrical system, or track switches, for instance. So we have a video that is rather downwards or straight ahead or upwards. And we also use different data sources because bear in mind that visual is very important, but we do have maybe dark evenings, or we do have a number of tunnels, and we would like to use other techniques in order to see what is going on at all times. So we use also laser and thermographic techniques in order to have a more complete and continuous coverage of the network. For instance, pattern recognition has been applied to the analysis of track geometry. We are using, in collaboration with a research institute, a machine learning algorithm. And as always, the algorithm doesn't do the whole work. We have very good track specialists that gives a good idea of how to have a good data set and how to have a good algorithm in order to have the results that are relevant for us. So we need to spend some time into teaching the machine and into really having the data that is relevant for this analysis. So that takes work, and it is promising. We have tried to see synergies between the different initiatives. And if we could summarize about digitalization, what is the value here? Of course, we see that we have new forms of digital data. We can have more frequent digital data. We had it before, but we can have more frequent, and we can have also a new usage of digital data. We see a value into not only have multi-sensor approach to get to different situation, but also multidisciplinary approach, because what could be important to a person from a special discipline may be even more important for another discipline. And it's really a system approach that we would like to have in order to actually get the pleasant surprises, if I should say, about finding where the problem is and trying to correct it. So we would like to optimize the inspection routines given the new knowledge we have about these different projects. I just named 3 of these or 4, but we have a number of projects that together can help us in the way of optimization of these routines. The main advantage that we have into using more digital data than before is that we can use less people along the tracks that because of security concerns would either reduce the speed or stop the track. Now we can have the tracks open and we can have traffic simultaneously to the measurements. And that has a lot to say when in many areas we only have a single track. So we would at the same time try to reduce delays as compared to what we were doing before. And that means increased availability and increased capacity. And those are the overall goals that are part of our business strategy. When I showed you the little house, safety, of course, and then more for the money and trying to have the customer a customer-centric approach, because delays are hardly ever popular. So business strategy actually dictates how we can go forward. And that's what we are trying to do, is to have a good anchoring of those different innovation initiatives in our business strategy. Yes, thank you.
So Isabel, I'd just like to say thank you very much for sharing these ideas. It sounds like you've made some fantastic progress and you've got some quite unique aspects to your approach, and obviously driven by your objectives and your unique circumstances with the topography and the weather and things like this. I guess there'll be some parallels with the next speakers as well, but I think there's some quite unique things that we've discovered there, and I look forward to diving into those in the question session later on, particularly a bit more about what this means in terms of interdisciplinary. We hear about this term a lot, and thanks for the examples you gave, but maybe we'll be able to dig into that a little bit more later. So thanks very much for your presentation today. That's great. So yeah, we're going to move on with our next speaker. So from the next speaker, we're going to learn something about the Finnish strategy for railway infrastructure development and digitisation, including the National Transport System Plan, which sounds like it's quite a comprehensive thing, and also to learn about digital and ETCS over radio frequencies. So from Digital Vela, the digitisation project manager, would like to introduce Mr. Juha Lehtola. Thank you for joining us, Juha.
Thank you, Daniel, and thanks for the opportunity to present our Finnish strategy here in this Scandinavian Rail Optimisation virtual seminar. Yeah, if you put the next slide, please. Just some words about me. So as Daniel already presented me, also Juha Lehtola is the name, and I come from the Finnish Transport Infrastructure Agency, so that's a little bit easier for not native Finnish speakers than Väylävirasto in Finnish. But anyways, it's an agency which is equal to infra manager of Finnish railways, just to get an understanding for where I come from. As Daniel, thank you. You presented I'm the project manager of the EFTMS program in Finland, and we call our program a little bit with a wider perspective as a DigiRail. I'm quite keen on the digitalization of the railways, and my background is from signaling systems. But then in the next slide, there is something about the content of the presentation. So as Daniel already mentioned, so we have a national transport system plan built at the moment. So we call it the Traffic 12 because it's a 12-year program for traffic infrastructure development, and it's quite interesting and a very, very new thing in Finland. Secondly, about the DigiRail, our project for digitalization of Finnish railways. Then something about our idea about ETCS over IP-based commercial radio network, and something about our pilot regarding to that. And the next one. And the next slide is straight from the Ministry of Transport and Communications from Finland. They are responsible of the National Transport System Plan. And this is, as I mentioned, this is the first very comprehensive long-term plan for the development of transport system in Finland as a whole. And we are not talking only about railways, we are not talking only about digitalization, but we are covering all the transport modes. And then as in the previous presentation, also the customer and the end user is very important in the planning. So we want to, let's say, enhance the transport infrastructure to serve as or let's say what's best for the end users. I'm talking about passenger services, freight trains, also other transport modes. The plan will be drawn up for a 12 years period, and it will be updated each government term. But the interesting thing here is that the plan will be accepted by all the parties in the government. So it's not like let's say traditionally, so that all the new governments, they want to have their finger on these investment projects and everything, but this is now something that all the parties are going to accept together, and then it will serve as a basis for the next 12 years. And of course, there is a need for adaptation time to time, and now they have decided so that it's every 4 years when we have a government term there. And the Ministry of Transport and Communications is responsible of the preparations there. There is a very close interaction between all the stakeholders here. And this is let's say this cooperative way of working in Finland is nowadays I would say normal. So we take into account in all levels all the stakeholders, and we want to have this discussion with everybody that what would be the best possible solution for different kind of things. And the most important thing now here in the National Transport System Plan is that at least the aim or the target is at the moment that the funding would be fixed also for the projects that are in the plan. And now there have been some draft versions about the plan, and now it seems very likely, at least, that the DigiRail and the digitalization of the railways would be in the plan, and we would secure the funding for our very interesting and important project. Next slide, please, about the DigiRail then. We started in May 2019. We started an ERTMS study. So, but in the very beginning of the project or the study, we realized that ERTMS is definitely just the starting point for railway digitalization, and actually that should be our target in the end. And that's how the DigiRail was born. And I think it was a very good decision in the beginning to switch the focus a little bit further, because when we started benchmarking that what happens in other countries around Europe and also a little bit globally, we realized that okay, many other countries are also doing this digitalization work, and we were quite happy with the decision to widen our perspective there. April this year, the final report was issued where we stated that the ERTMS solution, or what's good for the digitalization, is that we need to set up a modern radio-based ERTMS. And that's why that, of course, we want to get the full benefits from the digitalization. And that's why we decided that, okay, we need to implement for the whole country a modern radio-based ERTMS. And there is also, I want to highlight that we are not talking about, for example, anything that is currently spoken in the ERTMS world is levels 1, 2, 3. We want to be a little bit beyond those levels, so we are talking about modern radio-based ERTMS. And we really want to be prepared for the future and for the evolving technology, and we want to build up or set up the basis where we can in the near future and also in the little bit further future we can then take into use modern technologies, because these railway projects or railway installations, they tend to have very, very long life cycles. So if we build now something to the network and that's the life cycle is like 25 years, that's not, of course, very suitable for all the future development. So by that, of course, the interfaces are very, very important. But at the moment, we are working on a development phase for the national rollout. So we started pretty much from scratch when we started talking about modern radio-based ERTMS, and now, let's say, half a year or something like that, we have been working on it very, very heavily to develop and to get an understanding that what we actually need to do when we are talking about modern radio-based ERTMS. The cost estimation that we made in the study phase is for starting from this year until 2040 is a little bit over 1.5 billion euros, and that's covering the whole network, whole railway network for the new system. And as I mentioned in the previous slide already, the National Transport System Plan should fix the funding for this. And this is definitely something that is very new in Finland also, that we can even talk about this long project and talking about fixing the funding for this long period of time. As a time frame, we have the development phase now started this year before the summer holidays, and we aim to end it until 2027. And during that 7 years period, we are building up a test track first, which is not for any commercial use. And then after, let's say, couple of years, or in 2025-26, we're planning to build a commercial pilot from this system. And nationwide deployment would then be at 2040. Of course, in the development phase, we are looking into details about this deployment plan. That would it be suitable, for example, to a little bit speed up the project implementation? At least I would say that we are not going to do it any slower than that. So that's already 12 years. So Finnish railway network is roughly 6,000 kilometers. So it's quite big network, but at least in 12 years it should be quite easily deployed. And as I mentioned in the National Transport System Plan already, that we have a really, really good cooperation, or the mentality is that we are making things together in Finland. And this is also something that is very important in the digital project, and that's why. And that's also very unusual for projects to have the ministry, the infra manager, the NSA, traffic management company, the railway undertakings, and everybody, all the stakeholders, they are in the DigiRail. Everybody is working for the same target. And at the moment, we have 120 people working for DigiRail, and that's something also very unusual. And I'm really happy that we have had the opportunity to get so many people involved, and we need all these people, because we have a lot of things to do. And also we are quite much putting effort to international cooperation especially with our European colleagues. But next. So why DigiRail then? As I mentioned, so DigiRail is a solution of the future that has considerable advantages. The digital platform will be enabling new ways of utilizing data and implementing new technologies. such as already mentioned this afternoon, also IoT, using big data, these kind of things. So we gather a lot of data from our network, but we are not really utilizing it very well. But with the DigiRail project, we plan to do it. Then we are Europe. Let's say we are talking a lot about climate change, and then we see that this DigiRail has a boost on the climate change control efforts. So of course we are offering better services for passengers, a little bit lower times to transport or go from home to work and these kind of things, and serve better the passengers. And also very important is that we want to serve better the freight business. So we target that we can get even more people and more goods to the rails. And we see that DigiRail is the perfect tool for that. We have been making a lot of calculations about the capacity increasing on the railway with the DigiRail. And in some specific parts of Finland, we have calculated that even up to 30% is possible to get more capacity. And what we found out is that when we make, let's say, small infrastructure projects simultaneously with the DigiRail, we can definitely get to the 30% in those locations. And at the same time, when we are deploying for the whole network a new system, we can of course plan or design the most suitable solution for all the different parts of the network. That also gives us a lot new capacity compared to the current situation. Okay, higher level of safety. The safety level of Finnish railways is extremely high at the moment, but we see that with these new technologies, we can make it even more safer. Okay, the continuous communication with the infrastructure and with the trains, and then also level crossing safety, and then people working on trackside. So these are the three main things that we see that we can increase the level of safety. And then improved quality for passenger services through better punctuality and predictability, and disruptions also a little bit lower. Then one very important thing also is that usually railway investments, they have a quite big carbon footprint impact, but we don't have that. And okay, ERTMS will be built anyway, so why not get the full benefits out of it? And as I said previously, the focus is on end user benefits. And if you can get the last slide still, something about our ETCS over IP network. So we are piloting ETCS over IP-based communication for mainline operations. I assume that that's the first time in the world that we are doing this. And we are targeting to comply with all the FRMCS specifications, whatever there comes. And the procurement is ongoing, and we start the testing 2023. Big things, what I think we're talking today also, possibilities for satellite-based communication and localization, and 5G is of course very important as a backbone for this network. And finally, let's say Finland is usually being the country who looks at what the other countries do, but now we want to be a forerunner, and we are investing quite heavily for the future. And behind you can see a nice, let's say, a picture of DigiRail that we want to put DigiRail on one picture. Yeah, but thank you.
Thank you so much, Jutta. It's a really great presentation. I'm sure there's lots more you could tell us about this program. It's a massive undertaking, and you know, I guess we get a snapshot overview here. I guess some of the things that jump out at me, you know, there's lots of different stakeholders. Maybe we can get into that a little bit later. How do you keep them all happy? How do you stop them from fighting amongst themselves and things like this? I'm very glad, you know, that you were, you know, sort of mentioning the topic of climate change and, you know, the impact that you can have here. This is something very close to my heart, and you know, to move more people and goods on the rails is clearly you know, an objective that aligns with Shift to Rail, the European Commission's you know, mission, and also you know, I can see that you know, that you've got a lot to because it's kind of green fields, you've got a lot of opportunities to explore here, so maybe we get into that a bit later as well. So thank you very much, Juha. We're going to move on with the agenda. I'd like to mention that we have the next speaker, who may be familiar to you. You can see him here now. He's appeared before on Ben's events, and we will discover something new today, I hope, about how the company collaborates with different stakeholders and how we can move fast in our innovation and to get a view on the best practice approach. So I'd like to introduce from OSIsoft, the Global Transportation Industry Principal, Mr. Matt Miller. Welcome.
Thanks, Daniel. Perfect. Thanks, everybody, and thanks for your attention. Thanks, Ben, for the opportunity to share. You know, just Daniel introduced me a little bit. I have global responsibility for all modes of transport, and I have the privilege of working with a lot of rail companies throughout Europe and the world, as well as other transportation modes. One quick introduction of the company I work for is OSIsoft. We spent the last 40 years helping people do data transformation. And my job basically is to help our customers improve time to value. So when I looked at what topics to kind of share today, I thought maybe we would talk a little bit about the current challenges and how the last 6 months of impact, what those challenges look like, and increase the urgency for pace of innovation. And I'll share some insights that I've got working with the folks I've been working with. I wanted to spend a little bit of time talking about how to drive better collaboration amongst stakeholders, how to fast track innovation throughout really complex organizations, and maybe a couple of examples in the EU railway. So that's what I thought would be interesting and insightful. You know, when I started talking after again in the last 6 months about what some of the challenges are and what's changed, Isabel mentioned the aging infrastructure, and what we see in addition to that is that a lot of the large CapEx projects are being postponed, so that people are not necessarily able to get new rolling stock, and some of the large infrastructure. It was exciting to hear Juha talk about the large investment they're making in Finland, despite that. But a lot of other folks are getting some of those capitals put off, so they're having to deal with aging infrastructure and will for the foreseeable future. We're starting to see increased cost as cleaning cost and other types of costs to be able to operate increase, as well as decreased ridership, which I think somebody mentioned already, that 70 to 90% we've heard numbers of decreased ridership depending on the network and what's happening. Freight might be dramatically different depending on the mix of freight. I know in Scandinavia there's a higher mix of freight on the network, but all these things are creating a significant operating challenge. On top of the traditional graying workforce issues, we also see change in how the workforce has to conduct their daily activity, having to work more remotely, not necessarily being able to get to site, not being able to do some of the standard processes have changed a lot, and ensuring the health of the workforce while they're being deployed, not just the safety. So a lot more complexity in that part of the operating condition. And of course, last but not least, the security and privacy. As we go into a new intense focus on cybersecurity and dealing with privacy issues, both for health and other things, there's profound challenges and obstacles in getting some of these new solutions to market. So in general, it's shifting from do more with less to what I say is doing much more with much less. I almost said nothing, but it's generally not nothing. Usually there's something in there. So, of course, when COVID hit, I think it put a lot of people back. A lot of a challenging operating environment became a lot more complicated. But you know, the positive part is there is a point to rally around. I stole a quote that was attributed to Plato. I'm not sure if that's actually how it translates from Greek. I didn't check that, but it really emphasizes that in every setback there is an opportunity, and that opportunity is to get everybody on the same page and to rally around and to be able to innovate, to help drive new solutions that are really required to make things work and for people to I'll say survive or thrive through this really trying period. Isabel also mentioned a lot of different stakeholders and a lot of different ways to work, right? Information that can be used by lots of different groups for lots of different problems. Organizationally, as you drive many of these different features to a level of excellence, they call that overarching operational excellence. And each one of these get driven at different paces depending on the situation of the organization and the business environment. But the idea here is really thinking about new ways to work, and more importantly, how to work together, right? How do we take some of the opportunities in front of us? How do we get everybody moving in the same direction and innovating and driving continuous improvement in all phases of operations to achieve their goals? Perfect. I thought I would start with a different kind of example. And I guess for those who may be on the call, I know I can't ask if people know this guy, but in your head, I guess you can claim victory if you actually know who this guy is. I wanted to bring this up as an example of innovation or missed innovation. This is one of the most notorious misses of innovation in our history. I'll give you a little hint who this guy is if you don't recognize him, and it probably isn't too surprising. In 1975, he had this outrageous, crazy idea that essentially changed the world as we know it. And he patented this idea through the absolute world-leading company in the field. The company didn't, although they supported the patent, they didn't invest in this idea because it was out of their business model. They are one of the very best at continuous improvement, but this didn't fit in their normal business process. His idea, essentially the lack of that investment, meant that they were practically out of the business by the 1990s and filed for bankruptcy in 2013. Everyone on this webinar has at least one of these on them at the moment, and maybe two or three. So hopefully somebody have figured out who this is. This is actually Steven Sesson from Kodak. So this guy is the guy who invented the digital camera. So I highlight this really as an outrageous idea that people weren't able to figure out how to grab a hold of and make operational, that turned into one of the classic misses of all time, as other people drove that innovation into the next the new paradigm, into a next phase. I thought that was a good tee up to try and identify where some of the opportunities are for improvement throughout this challenging time. I wanted to highlight maybe a little bit of difference between continuous improvement and true innovation. And I kind of look at this more like evolution versus revolution. And there's a time and a place for both. And I think both are really important. So to compare and contrast a little bit, continuous improvement's usually the refinement of a new idea, a creation of new way of looking at things, and a new application or an idea, where innovation is a step change, and it's often a new twist on an old idea, just applied in a really different way. As things move forward, constraints change, and looking for those constraints, retesting those constraints, and looking for ways around those constraints are the difference between continuous improvement and innovation. So incremental change and these step changes that profoundly change how you do things. Continuous improvement really presumes that you're using some traditional business and frameworks, and innovation often is highly disruptive. Continuous improvement also is limited to current technologies and available tools. and innovation often isn't. Sometimes you have to invent something completely new to make that happen. Continuous improvement, if done right, is really everybody in the organization's responsibility, where innovation, because of the nature of it, is often relegated to a specific group. So what this looks like from end to end, if you're trying to drive time to value, you have an idea through design, build, test, validate into production rollout, right? There are steps in these critical systems that you have to take and move through. You can't really avoid them completely. But you want to be able to improve that cycle and look at the time and increase your time to value as tightly as possible, staying focused on the things that deliver the most value. This is a classic continuous improvement cycle, very important in this time to drive. But if you think about innovation, as you're identifying new ideas, there will be some ideas in the design process that don't fit. That means that I can't execute on those ideas. And being able to drive those out into a separate innovation cycle and have the teams of people be able to look at that innovation, understand the barriers, and look at ways to break that down can be the key to dramatic success with those ideas. I found this, a good friend of mine is an innovation consultant in Silicon Valley, and he and I were chatting about some of the challenges in the industry today, and he drew my attention to this little diagram, which I thought was useful and wanted to share. It really talks about the end-to-end process. If you think about the innovation process, a lot of time in understanding and ideas, followed by a focus, a solution, some unifying idea that people agree is the right direction. Oftentimes there's a gap or a gasp, a breath, before people go into implementation and production. So this is kind of what we would call a hyper innovation or a fast-paced innovation type process. I wanted to highlight that a lot of people have a bright idea and want to push that idea directly into this process. They want to go directly into the clarity implementation phase. This does a couple things, and it increases your chance of failing, and it also increases the expense. And it also does something organizationally by leaving all the people who may have been involved in that ideation and understanding and bringing them on board is missed. So although this is really tempting, and to avoid all those meetings and all the potential conflicts, it's also a potential miss of bringing everybody on board and getting everybody to collaborate in a consistent way. Part of the reason why this is tricky is because oftentimes these discussions are based on opinion rather than based on data. So having a good data foundation to drive through this process often is absolutely critical. Customers who become data driven say that this is probably the most profound cultural change that they experience, is that the group working through this process now can work with data to try and innovate and determine what the best results are as they go through their organization. So let's talk just for a second about liberating data, liberating innovation with the power of data. I often highlight, maybe if you've seen a couple of my talks, you've seen this slide before in different variations. I tend to want to emphasize that there's a little a and a big A in analytics and applications, meaning that users, subject matter experts, and data scientists, users of all different kinds from this data set, want to use different tools, the tools they know well, to help experiment and drive value add. So analytics being the the extension of the information, adding knowledge, infusing knowledge, and enhancing that, means that there's all kinds of opportunities to test and try different things using tools that people are comfortable with, and empowering those tools can be wildly valuable across the organization. Analytics tend to take a specific maturity model. At OSI, we've been kind of watching this maturity model carefully, and we've been trying to measure the business value that gets created in each of these phases. What we've noticed is that the first and foundational pieces of those first couple steps in the maturity model tend to produce the largest amounts of value. And that's really key because it helps understand what happened and why it happened. And it sets up that ideation, it sets up the stakeholders to have that discussion and to help drive what the best total outcomes are. Now, once we've identified those outcomes, then we can automate those with more advanced tools and then make that happen and make it repeatable over and over again. But the key has really been back here in helping get everybody on the same page and build that strong foundation. Good. And you may have seen the described this way, right, as you go through different types of diagnostics. So I wanted to take a minute, talk a little bit about collaboration, communities, and standards. There is a whole lot of opportunity and nobody does it alone. There are lots of different ways to drive innovation, hackathons, workshops, all kinds of different events, R&D alliances, universities. I wanted to tap on a couple shortly. One is the Cisco, this is an out of industry one, the Cisco Hyper Innovation Living Lab. Cisco brings together people from all over, different experts on a given problem. They've stripped away IP. They basically created an environment so that they can share in the IP, and they innovate and create some outcomes in a very short period of time. This is one that happened in Berlin a year or two ago. SNCF is using, they started with hackathons and innovation. They moved to an acquisition for AI and ML, and now they've kind of matured into a full data lab. Really impressive, sharing with their whole ecosystem and allowing people to innovate internally. The last workshop we did on infrastructure, Paul Kutvik from ProRail shared their learning lab, their data lab innovation, and that process. If you haven't seen that video, you can check it out. Thanks, Paul, for letting me bum a couple slides. But again, it's about exposing all the data that they have, getting involved the right users in that data set, and creating this across their whole ecosystem, including their business partners. Good. So I was going to put some university examples in. I know Isabella mentioned one earlier. I've been working with a number of them across different. It is a great resource that should be leveraged. I won't go into a whole lot more into that. But to sum up, I really wanted to emphasize, to help drive innovation across your organization. I would recommend ideate profusely. Spend more time in the idea phase. Work to empower all your stakeholders and get them on board. Don't be afraid of those crazy outlandish ideas that quite frankly might present a huge miss for you. Use data to evaluate the ideas and options to get the best possible outcomes. Make sure what you have fit in your organization, and when they don't, drive it into a specialized innovation process designed to break those down. I think Isabella talked about don't falling into that technology trap, and bring everyone along for the journey. So those are the thoughts for me. Hopefully that was insightful.
Matt,
Daniel, you there? I'm not hearing you.
sorry, I think we got a double mute there. So I just wanted to say thanks very much for making that presentation, and very insightful. I think it will be for everybody in the audience. And also thanks for making it current. A couple of the things that we'll touch on later into the panel discussion will be integrating this domain knowledge, and maybe we can look at the kind of tools and how you can evaluate those tools in a bit more detail. Some of the things you mentioned about integrating education and academia, hackathons, things like this, really insightful as well. So thanks for bringing that perspective. And now I think we'll move on. So we'll see you in a minute, a bit later. Okay.
Thank you.
Great. So we're going to move on with our next speaker. It's you'll discover in this session more about using new technology to build in the building of new main lines. It's quite a big project, or a big aspect of the project for the next speaker. So we're going to look at the newest or the latest project methods and how new technologies can be applied from traffic verket. I think that's probably my very English way of saying your name of the company, but the head of strategic construction support. We welcome to the panel Mr. Johan Sundin.
Thanks, Daniel. And you can also say the Swedish Transport Administration, as that's the official name in English, so that's no problem. Some words about me. I have worked within the Trafikverket and for the past 25 years, and for 20 years I've been involved in the major projects, rail and road projects. And I am a steel and concrete man, not in digitalization as such. Yes. I'm going to talk a bit about, make a short introduction about Trafikverket and our project, and then talk about the preparedness for new methodologies within this industry, how we work, and how some examples of challenges that we face within the project, and how we are using new technologies. Yes, and the Swedish Transport Administration, we are responsible for the long-term planning of the traffic system in Sweden for road and rail transport, shipping and aviation. And we are also, and that's the big thing, responsible for construction, operation and maintenance of the state road and railways. And similar to Norway, Sweden is a very long country. I think we are even longer than Norway. So we have 14,000 kilometers of railway and 100,000 kilometers of state roads. And we also run railways in the far north of Sweden. And of course, we have some climate challenges if we're going to construct anything in north of Sweden. That can be very hard weather conditions. We are 9,000 employees, and we had a turnover last year at about 5.9 billion euros. And also in Sweden, also similar to Finland, we also have a national transportation plan that covers every 12 years, and we decide on a new one every 4 years. So that, and in the last transportation plan decided 2 years ago, we got a lot of more money, especially for investment in railways. So that's a future business in Sweden is really railways. We have a lot of main lines in Sweden, but they were built about 150 years ago, and we have virtually the same railways as in Sweden. Of course, we have upgraded them and so on, but we have a lack of capacity, especially between the 3 biggest cities, Stockholm, Gothenburg, and Malmö, where we have existing main lines, but as it's so popular in Sweden to travel by trains, it has doubled the last 25 years. So we have a huge lack of capacity, which also makes it hard to maintain the existing railway in a good manner. And we also in Sweden have set up a goal to have fossil-free society by 2045. So that has led to the decision to build new main lines between the 3 biggest cities. So we have at the moment we have ongoing projects. They are financed, fully funded, and it's the East Link project, my project between south of Stockholm and down to the city of Linköping. And we have Gothenburg-Borås, and in the south of Sweden also one project. And for the stretches in between, we have made early feasibility studies, but they are not projects and they're not financed in the current plan. So my project, the East Link project, we're going to build 160 kilometer double track. The science speed is 250, and we're only going to run high-speed trains up to 250 and fast regional trains on these new main lines. No freight traffic. That makes it more possible to squeeze in more traffic. The budget is 5.5 billion euros. We expect to have it ready for traffic in 2035. Some parts perhaps even earlier. And this is what we're going to do. We're going to build 20 kilometers of tunnels. 150 bridges, 5 stations, and 20 million cubic meters will soil and rock masses we have to handle. And this is a very densely populated area, so the city of Linköping in the south of this stretch is the 5th biggest city, and the city of Norrköping is the 9th biggest city in Sweden. And we're going to connect to Stockholm area where we have 1.5–2 million people living. Yeah, if I then move over to more the topic of today, the preparedness for new technologies, and the Swedish Transport Administration, we are a very decentralized organization and very highly digitalized. So when the COVID-19 hit us half a year ago, we were quite well prepared, I think. And from one day to the other, we moved from about 1,000 people were working from home before, and now we're about 6,000 people working from home. But that's turned out very well and functions. And when we move to the consultancy firms that works for us, they are most often very big companies that are operating worldwide. So they work internationally in many countries, and they work around the clock in different parts of the world. Technically, we use for design, we don't do any drawings today. We use BIM, Building Information Modeling, where you design in a digital model for design of roads and railways, which means that you can look at what you're interested in and don't have to look at the physical drawings. And you can also use the information digitally in some way. I'll talk about that a bit later. You have talked about the new digitalized signaling system, ERTMS, and we are installing that on all new railways in Sweden. And we also have a program worth about 3 billion euros for installing this on the existing railway. So that it's ongoing very well. And we also have document management system, for example, for procurement. So you don't provide any papers. You just bid digitally, so on. And I believe that the pandemic has shown that the industry has a high level of preparedness for new technology and also works with that. I can mention that we had a supply dialogue with consultancy design firms for the railway technology early, just before summer. And we usually have those physically with participants from many countries. And this year we had it totally digital and through Skype, and it worked also very well. So that's one example. If you then move how we work at the EastLink project with new technologies, at the moment we are preparing the early design that makes it possible to get all the legal permits that we need from the government and to make it possible to acquire the land that we need. And then the information stakeholders is very important at this stage. And through virtual reality, we can visualize the plans for neighbors, companies, and municipalities that are affected by the new railway. Ordinary people are often not so used to read drawings. So it's better to show them a model or even a film. And during the construction phase, we can also use new technology. For example, we can have automated text messages to neighbors about email and blasting and so on. That's one example. When it comes to the construction, then we have automated machine control of excavators and drilling rigs, which means that you could feed the computer in the excavator with information from the digital model design through the BIM. And I believe that before we are ready with this project, we will see on our sites autonomous excavators and lorries as well. Regarding planning, we have tools for time scaling, which is very good because you can see if things happens in the planning and the progress is slower or faster. You can see what results that will give for the time schedule. Because you use new technology for quality management, where you can monitor the project process and performance on the construction site. And we can also interact with the planning tools. And also for risk management, we can identify, assess, and make countermeasures through new technology and to aggregate information. We have I've taken the 4 biggest challenges that we face in this project and as examples and to mention how we use new methodologies. For example, mass management. As I said, we're going to handle 20 billion cubic meters of soil and rock materials, and 1/4 will be surplus this. So that's a huge challenge to get disposed of all this material. But if you use this BIM technology, it makes it possible to optimize the design, and we also can use digital tools to plan and administrate the disposal of surplus material. We have the travel centers. There's very complex passages through the cities of Linköping and Norrköping, and there are many stakeholders, and they have the city councils have big plans for this area. So it's a very important passage. And as I said before, BIM and virtual reality makes it possible to visualize the different alternatives to the stakeholders. Yes. 2 more challenges are the ground conditions, and as regarding the same as in Norway, we have everything from very good grounds material up to very bad. So some areas don't demand extensive ground reinforcement. So we'll use ground penetrating radar to optimize the reinforcement measures and minimize costs. Using the radar makes it more, we can get more information, know more than using the traditional methods. And the perhaps biggest challenge in this project is the resources and competence, because we have a lack of skilled and experienced people, both on the client side and on the supply side in Sweden. So having digitalized project documents and project databases, that makes it possible to work from anywhere in the world and 24/7. And this doesn't apply for all the staff, of course, but it makes it more easy. And hopefully we can use also translation applications in the near future, because for legal reasons all documents in the project has to be in Swedish, and then we'll need to make it possible to translate them if I have foreign suppliers. And so yeah, that was very short about the Link project and how we work. We have our own website in English where you can follow the progress. And if you have any questions later on, you can contact either me or my colleague Pelle Hovland, who is the procurement manager for the Eastlink project. Thank you.
Thanks so much, Johan. It was really interesting to hear about this project. It's such a huge project and many aspects to it. We'll dig some more into some more of the detail there. Particularly, I think it's interesting to see how you set up these processes, because you're doing some really cutting edge stuff, particularly with the BIM and the VR and so on. It makes sense to me, and I think this is an interesting aspect to explore later in terms of the communication elements that are required in such a huge undertaking. So yeah, well, it's time already for our final speaker of the day, and then we move into the panel discussion. We'll discover, I hope, some more about IoT architecture and how to control costs and so on. I know this gentleman's an expert in this area, and hopefully we'll see how that's related to maintenance and how analytics can lead to new business models as well. So from Stimio, I introduce to you today the founder and CEO, Mr. David Dorval. Welcome, David.
Thank you, Daniel. And thank you, Ben, for inviting me to this event. My name is David Dorval. I'm founder and CEO of Stimio, a company that is based in France and has obviously strong links and commercial relationship with the French railways. And we are specialized in developing IoTs, industrial, and we address two markets, railway, both rolling stock and infrastructure, and also utilities, domains that have also a big infrastructure that must be maintained. Okay. Okay. So the agenda for today is just presenting Stimio first, then giving you some insight on railway and IoTs and why it's a perfect match to our opinion. And then we'll switch to real examples. We have done this last month. That is monitoring track defects and catenaries, thanks to IoT and the benefits we have seen. And then we'll see how IoT and AI, and more especially Node AI, is very important for the future. So Stimio, why we exist is that we exist because IoTs requires a lot of technical skills we have, and our goal is to design and provide energy autonomous IoTs, a solution made of modular hardware, embedded software, a lot. That is a big part of our activities is to develop embedded software. And we also develop wireless transmission and data services in the cloud to serve the rail and infrastructure industries. Basically, you can define our activities in three parts. The first one is what we call data generation, is acquires data on the field that are made of simple pressure, vibration, position, very important, and also some strain, all kind of data that can be served by small sensors that does not consume a lot of power. All these data are crunched and then transported to through the best mean with the telecom, so what we call data transport. And here we use the best technologies that cover the needs. It could be long range, low power. It could be short range. It could be everything satellite. And so we deliver data to the cloud, and where we do many things in the cloud. We obviously give the visualization. We also monitor all our devices so that clients know what is their fleet, the health of their fleet. And we also develop models that helps to predict what will happen in the future, and also develop kind of a real database of equipment in the field. Obviously, to do that, we can combine it with external data, typically weather forecast, and everything could be also linked to the customer IT, so that we deliver to the customer either raw data, either crunch data, and either predictive data. So railway and IoT, why it's a perfect match? As you say before, trains and infrastructure are very old. Average age of the infrastructure in France, I think it's 37 years. And when it was designed and built, IoT was even not existing at all. But the advantage of IoT is that it could come after an easy way to upgrade the network, put sensor anywhere, and to have continuous and real-time monitoring in the train, which is not the subject of today, but it could help to do retrofit without cables that has a lot of cost. So it means you can put IoT everywhere. They are autonomous for years, and they can give data that are then analyzed elsewhere very easily. So here I put some program we address. So there is the what in trains, at the door pressure, whatever in the train, or elements of the trains that could be monitored by IoTs, and also 3 types of activities that are related to the network. So the catenary, the switch and crossing monitoring, and the track defects. And we'll see how some of these, how IoTs, simple IoTs, has helped a lot for gaining maintenance cost on this subject. The first example I would like to share with you is the how IoTs help to detect track defects. The concept is that we have IoT devices that is autonomous for years, and that is attached to the train, to the frame of the train. And we have more than one, between 5 to 10 per train. And devices, sensors that are embedded in our devices measure position, speed, acceleration, and also record shock profile. It means that we have many accelerators, MEMS accelerator inside, and that we record a lot of data. Then all this data are combined between the different measurement units put on the train. Location is recorded too. And we send the shock profile to the cloud, where an analysis tool is able to identify the severity and classification of defects, of track defects, based on trace speed, location, and mile marker. For instance, mile marker means that some track equipment generates shocks, but we don't care. But we have to know where they are, so we can discard this event. And the concept that is based on statistical and differential measurements allow us to follow defect evolution, detect the initial defect, follow evolution over time, and optimize costly track maintenance and repair machine usage. For this, because track maintenance and repair machine are used during the night often. So if you know where it is, you can more easily fix the defect and more efficiently. So the first thing that is deployed, being deployed in Mexico. The second example is related to the catenary mechanical tension. Sometimes we have huge weather changes and heat waves that have an impact on the catenary tension. And based on the catenary tension means that you have to adapt the service against the state of the catenary. So what we do here is that we measure a counterweight height. And we have a system on the left of the slide here, made of a measurement of the height and then wireless transmission. We also measure the rail temperature thanks to a fake rail that is just closed from the real ones. And we measure the catenary temperatures. On the right picture, you can see the systems is attached to the catenaries. And even when the catenaries are covered, it works. And with these 3 types of measurements, we combine them. And we first have the time series. So we measure on a quarterly basis. I mean, every 15 minutes, we measure the temperature. We measure the height of the counterweight. And we also measure the measurement as a rail temperature. So we have the basic time series that is good to have, so you can see how it behaves, but does not give a lot of insight for infrastructure manager. what we do in the second step is modeling the catenary behavior as a function of catenary model and a local effect. It means, for example, the temperature. Each temperature means Z8 of catenary. It's also completed by lux monitoring. And we do analytics and say, okay, we have a model of catenary behavior that is related to the temperature. And then we predict the catenary profile up to 48 hours in advance, thanks to weather forecasts that are put into the model. And with this approach, we are able to inform the infrastructure manager to adapt train speed if required. So we do it 48 hours in advance or 24 hours. And so that we have a system that is directly linked to the infrastructure manager, and you receive a SMS or a mail saying, okay, beware that within 24 hours, you probably have to decrease the speed of the train because the catenary will be a bit weak. We are using the same approach with the same devices for icing detection up to 48 hours in advance too. And what is good is that we have one hardware, one solution. This is just software change, and both solutions are available off the shelf from sensor to cloud. Okay. So the saving and return investment we have seen is that in terms of field operation, it is a continuous monitoring. There is less time, less people, and you can know where the failure could occur. We are able to give them condition-based and prescriptive maintenance. And what we have seen is that the range of ROI is between 12 and 36 months. And we see that the maintenance cost can be improved by 30% and allow more train, more often a safer network. It's without counting the operational gains related to the better traffic. And for the catenaries, what we avoid is that the risk avoidance. I mean, if a catenary is broken, it's around 100K euro of damage, and overall traffic is interrupted, and there is also operational loss for the operators. And for the IoT and AI, I just would like to say a few words because our next step is to put some AI within our devices, very close from the data generation. Just because we were able to take very local effects that are not taken into account in the cloud. We are not related to the quality of the network, so we have optimum latency for data analysis. And we can do offline mode when cellular network is not available. And more importantly, having this kind of intelligence deported to the node, we have a lot of energy savings of IoT system. And energy savings is a key to have the IoT deployed in high volume because they are supposed to operate for years without being changed. Okay, so that's why Node AI that is offered by Stimio is a very good advantage for our customer. As a conclusion, individual IoT is small data, but the sum of IoT is big data. I mean, we can deploy a lot of IoTs all along the tracks to monitor every piece of it that could be completed by, for example, drone inspection. It's a very low total cost of ownership, and it's also a progressive approach for the deployment. You can start small and finish very big with IoTs without changing everything. as I said, drones are very complementary from IoTs because drone is an image, but it's not real time and not continuous, while IoT is a continuous measurement. So typically what you could do is that you inspect by drones, and when you see a potential weakness, you equip it with the IoTs so that you have a direct and continuous monitoring of a weak point. Everything that is measured is an IoT candidate for us. And AI and at node and edge level are already possible. And one other thing is that what we believe in Slimio is that equipping train with IoT to survey to monitor the network is a very promising things because it is based on a statistical approach, and what we can do with that, we can have first things very rapidly and continuous manner, and so detect upfront the defect, and then act on the network in a more efficient manner. Thank you very much for your time.
Thank you, David. Another fantastic presentation from you. I'm always amazed at the progress that you guys are making. I mean, it's so sort of rapid and consistent, and you always have new things to show us. So thanks for that presentation. And you know, I think just looking at all of the presentations today, it's been a real eye-opener. How much is happening, how fast it's happening, and how many brilliant people are committed to these things. I'd like to ask our panel to come back now and join us for the panel discussion phase of the session today. And whilst you're doing that, I'm just going to do a short introduction or maybe a small wrap up of what some of the things that we've talked about. I mean, we touched on the interdisciplinary nature of this. We started with Isabel, and then we realized, or we discovered also, that there's sort of multiple sensors and multiple platforms and multiple data streams and lots of different ideas to explore here with various stakeholders. And actually, we have to realize that with the scale of this investment, it's a huge commitment, first of all, for the investors and the stakeholders, but also there's lots of different stakeholders involved in the project itself. We have to bring those together over a long-term view, which is a challenge in itself. Then we have the importance of testing out ideas and understanding, what this data means. I love this phrase, liberating innovation. This is a fantastic phrase. I can't remember who mentioned that, but it was, I think it was maybe you, Matt, but I might be wrong. Anyway, this liberating innovation is the first step to liberating knowledge and liberating improved working practices and in the end profitability. How do we communicate these ideas? How do we ask the right questions? We touched on some elements here as well with some of the presentations regarding, particularly from Johan, on the VR side. I think that's the first time we've had a meaningful use of VR in the rise of big data and IoT in rail. Then obviously we've got the issue of resources and competences, and how do we bridge the gaps, and how do we integrate where we have lack of experience. And just following up there, we've got the topic of new data arriving all the time, and AI. Do you do processing in the edge, or do you do it in the cloud? There's all sorts of different options depending on the application and the objective. So let's start with the questions. Maybe, I mean, I've been receiving questions, just to let you know, from the audience, and I've been rushing, I've been writing notes, and I've been trying to consolidate those questions into some topics. Let's start with one of them, which is that Isabel started with the value and identifying the value of each of these innovations and why we do it and what we expect in return, and how to evaluate the impact. Then Matt followed up with time to value, the time frame. How long does it take to get some value out of these developments? And then I loved it because Johan brought in the preparedness for the technology, which is you know, another element that's really important. Now, just to let you guys know that Johan's camera's not working, but he is attending and he is there on the discussion, so we'll include him too. So let's start with, you know, how do we make sure that we are testing our ideas in a way that makes sense? How do we decide on where to put our investment? There's some big sums of money being talked about. I think we're going to kick off. Maybe let's start with Johan here on this, the answer to this. Johan, have you got any insights or ideas on this? How do we test our ideas?
Well, the good thing being a construction project is that we need to be hands-on. We can't, we haven't the time or the money to test new ideas that doesn't work immediately. So that's one thing. But of course, we sometimes we get in between. For example, this BIM, building information modeling, that I was talking about. We have great ambitions at Trafikverket about this, and it's a need also because when we talk to our the big construction companies, not least the Swedish ones, they say that, well, if you don't design and use BIM, we will not work for you. So that's a need for us to do that. And also, of course, I talked about BIM. It also has the advantage that when we're ready with the project, we will transfer the models adjusted for the actual outcome after the construction phase. We will transfer that to our maintenance division. So they will have, we talk a lot about digital twins now in Sweden, and so that's a mean for them to make the maintenance more efficient and to plan the maintenance efforts.
Thank you. Just for the audience, let's just define the digital twin briefly. The digital twin, as far as I understand it, is a simulation model of a real world object or asset built with using the data that runs in the cloud or runs on some sort of server infrastructure. Would you agree with that, Matt?
Oh, yeah, that's one good definition of a digital twin. I think a lot of people recognize there's kind of a design digital twin. There can be a design build, a build fabrication digital twin, and there can be an operational digital twin. There are subtle differences between those, but ultimately unifying a core and being able to leverage data across its life cycle is generally referred to in a big picture as the digital twin. This is one really important and exciting aspect of digital twin for sure.
Yeah, so we can have digital twins operating at all sorts of different scales. We could have them at a components level, or we could have them at a fleet level if we're talking about assets, or infrastructure, obviously in terms of infrastructure age or the classification or the maintenance profile and all kinds of things like this. So, okay, maybe we can go with that question to Juha, the original question. How do we test our ideas? How do we? You've got some big budget to play with.
Yeah, I would totally agree with the first comment on that, Johan, hands-on. So we definitely have to have some kind of platform where we can a little bit play with the new ideas also. They don't just happen in the office. The other thing, because we are very often we are dealing with the public money here, so the flexibility in the procurement is also very important. So let's say innovation in new models for procurement is also quite important. So because when you are using the traditional procurement, it's almost impossible to have real innovations in projects.
So what we're actually saying here is that innovation has to be extended across all aspects or all elements that have an impact on the project, rather than just say, okay, we do this great cutting edge stuff over here, but you'll be let down by your weakest element in. So we have to have a sort of a redesign all the way across the organization. So Dave,
if I can jump in. Yeah, no, I just want to jump in on a thought there. I think part of the European tender actually makes it more difficult to pilot and test some of these things because of the procurement process. I think there are rules and limitations, right, Juha, around what can and can't be done. I think that actually makes it more complicated, doesn't it?
Yeah, that's exactly my point. Yeah, if you set up a traditional procurement, you have to set all the minimum requirements and everything, and then the buyer already, let's say, determines what to do, and it leaves a very little space for innovations. But there are new models also for cooperation. In Finland, we have been using a lot of this alliance model where the buyer and the supplier or the other contract party work on together first in the development phase for what's best for the project, and then after the development phase, there is a joint decision to go to the actual building. And I know that in Sweden they have been also using this a little bit the same kind of way of procurement, but it's not exactly the same as alliance.
But certainly a radical approach is needed, because the old ways are not going to work on such a scale, yeah, and with so many changing requirements. I guess you're learning all the time about the way that requirements will evolve for such a project anyway.
Yeah.
So David, any ideas on this one? How do we make sure that we test or how do we evaluate our ideas and decide where to invest?
Yes, for me, there is two types of projects. The new projects, to build a new line, and it's years and billions of euros, and it will take time. And the how to better use the existing infrastructure, which means more train on time with a safer network. And for this, you can have huge gain using IoT, because you are saving maintenance budget, by the way. So which means that instead of sending people to inspect, you can do it real time, and you send them inspecting something else, or you don't send them to inspect. So the gains that you can have thanks by equipping with some small sensor or the lines or part of the lines, and then have a clever balance between number of IoTs and data in the cloud, because statistics is very important here. And there is a very huge gains that are ahead of us. What I can say, for example, in France, they want to reduce the maintenance. Not really changing the maintenance, but reducing the time the train are spent in a maintenance center. And if they don't do that, because there are huge equipment coming in, new train coming in, especially for Paris, they will have to build new maintenance center. So imagine the balance is that either I'm equipping the trains and infrastructure with the IoTs, or I'm building new maintenance center. So the choice is very quick. You have to choose the IoT, because the gain are so huge compared to building a maintenance center in Paris, where the lands are very expensive. That you have to equip the train, and that's the same in the infrastructure. I mean.
One of the things, just from a best practice, if I can get a final, or another note in, from an ideation standpoint and time to value standpoint, it's to test the ideas. A lot of times companies have a way that they prioritize, whether it's some metrics, some barriers saying if we can do this, but a lot of times if they can't test it, if they can't run it to ground in a small sample, they actually deprioritize those. To try and prioritize the ones that are actionable, and they can drive some real value from it, and it avoids wasting a lot of time. So what they say is fail, if you're going to fail fast.
Yeah.
Right. And yeah.
Yeah, fully agreed. I mean, obviously Nexio, relatively young company, 2015 founded, and we really integrated this MVP, minimal viable products approach.
Sound.
Daniel, you muted again.
Muted.
Yeah, hello. Yeah, be ruthless with ourselves, and don't, sort of choose vanity projects, but choose things that are going to be meaningful. But, it's an interesting question. It's the short-term impact versus the long-term objectives as well, because, some of these projects that you guys are supporting are, 12-year projects. And, it also leads me on to the next question in a way, is that how do you build the teams for such things? I leave that like that question, you know, as a simple question. How do you build such teams? Interdisciplinary was a word that came up. Who would like to take that one?
Well, I can start, Juha here. So it's well, I think it's extremely important to get different kind of people to work in this project. If we have a same kind of mindset with all the people, nothing will happen. So we need different kind of people from different kind of backgrounds. But then in the project, it's extremely important to take this into account. So we cannot assume that everybody, for example, understands all the abbreviations that we are used to be talking, all these ERTMS and FRMCS and blah, blah, blah. We have a huge amount of abbreviations, and we just have to take into account that people come from different kind of backgrounds. And then we were talking a little bit about the translation things. Was it also Johan who was talking about that this is something that we have been in DigiRail also talking a lot about, because of course the domain language or the dominating language is Finnish, but it's not so widely spoken outside Finnish country borders. So now we have taken a translation company inside the project, so they are doing on a weekly basis these translations, and we are following up all the time. So we are not trying to write 100 pages of specification documentation and then translate it, but in a much smaller scale. So, but this is I mentioned that we have more than 120 people now working for DigiRail. So this starts to be a, let's say, quite big company already to run. So it's very interesting, and have to be very flexible and trust people.
It makes sense. I mean, we have to think differently, don't we? And we have to solve problems, whatever they are. So to bring in a translation company, it's a no-brainer, but traditionally it wouldn't have happened, yeah? Isabel, you talked about interdisciplinary teams, and maybe you could share a bit of information. How do you integrate a broad or diverse crew of people from different backgrounds and education?
It's very interesting. We see the value of it. Again, we're dealing with projects that are not implemented yet, right? It's really in an early phase. On the line that Matt showed, we are still in this sort of messy phase where we try to find out what is actually doable. So we have quite a bit of creativity that is possible at this stage, at least. But I think it is important to strike a good balance between at least the commercial aspects that we can't ignore, or the overall objectives that I try to describe, and still this creativity. And then later on the project, bring along, we cannot do this alone, so bring along some of the ecosystem that we know nationally and abroad, whatever is useful. I do think, at least after 2.5 years in the rail system, I do think that people are actually quite more open than what I originally thought. And just this illustration of BIM, I think, is quite interesting, because you see that, okay, the information is digital, but it's not only digital. I mean, we've done digital before. It's a way to share the information between the different stakeholders and discuss in a way you don't have a very specific set of specifications that you stick with in years. You can discuss and adjust on the way. And I think this is a new way to work with the different stakeholders. And it's really interesting what Johan said, that, okay, maybe city officials already understand something from a drawing that is actually quite complex, but the complexity is back. Specialists can deal with it, but at least the different stakeholders can have a view, and I guess the negotiations can also speed up a little bit and speed up the innovation. So BIM is of course something we do regard also very positively as one of the measures that can be useful to share information and actually work with information with the different stakeholders.
just go to Johan quickly. Johan, I think you caught our imagination with this idea of using VR to communicate the ideas on routes and so on. You've got a lot of stone and rock to move. Better to move it from the from the right place to the right place first time than shift it twice, I guess. What sort of reactions have you had from using this approach, and how confident are you that it will deliver the value that you expect? To Johan first.
Did you mean the mass handling itself, or?
No, I mean using the BIM and the VR combination to try to communicate your ideas and plans to stakeholders to get them to. I mean, they can't. Not all people can look at charts and maps and so on.
No.
This is a new way of looking at things.
Because on a drawing or a map you can only see it 2 dimensions. But so it's very hard for non-professionals. But the 3D model makes it more, and even if you can see a train moving in the geography, it's much easier for sure. It was very good that we have this approach now, because we have to have it stated that to have public meetings for stakeholders and the public during this process. We have to have at least twice of these before we can get a plan approved. Railway plan approved. We have to get the meanings of the stakeholders. So now, when we couldn't have physical meetings, we had digital meetings instead, and it worked very well. And we had also a tool that makes it very easy for people to take part of the information and to make their statements and tell their views about our different alternatives of alignment.
So let's get down to it. What's the impact of having this new solution at your fingertips? How can we all use this approach to? I mean, does it make things faster? Is it clearer in terms of communication to the different parties that need to agree, etc.? Has anyone else got any experience of this? Johan, feel free to answer. Does it make it faster? And then we move on to other people. Sorry.
Well, I can take one example as well that isn't from Sweden or our product. That we made a study visit to High Speed 2 a year ago, and one of the consultants, they had a program where you could simulate the noise impact from the railway that was going to be built. So the stakeholder can hear, okay, how noisy is it going to be? Because they have such a tool, and so they can simulate the noise. So that's also one example of how we can use this technology for non-professionals.
So it improves transparency. It means that we can communicate more effectively, and it means that we can get consolidated opinions from the stakeholders. Is that right? Yeah.
Yeah, because also if you get the public opinion against your project, you have a very hard journey to make. So it's very important to have the stakeholders with you as much as possible. Some people will be discontent, but as many as possible.
Thanks, Johan, for that perspective. Obviously, we're fairly short of time to begin with. We're running out of time, but we've got 5 minutes left. And what I'd like to tackle here, we talked about getting good data. We talk about getting clean data. We mentioned about good algorithms, and we hope that we're going to have the interdisciplinary teams, that we're going to ask the right questions, that we're going to have the right tools for a dialogue to communicate between stakeholders and get good consolidation. But how do we make sure that we embrace this culture of innovation across the board? And in particular, how do we integrate valuable domain knowledge that we're possibly losing? So I think maybe we start with Juha, we start with you on this one, and maybe Matt can then comment, and then we go to David. So I'll let you guys. The question is about how do we integrate domain knowledge across the organisation to make sure that we set off on the right track?
Well, I think it's a really good question, because of course this utilizing and handling the big data and making it visible what can we have from there, or what. So it's a little bit hard to visualize. We were just talking about visualizing things, so might be a little bit hard to visualize, for example, for board members or these kind of things, that okay, we need to invest this or this amount of money to get to handle our big data. Then they ask, okay, why? And then, okay, because then we have data and we can use it. Okay, but why? So it's again, we are back a little bit on the visualizing and what are the effects. I don't know. It's a hard thing to do, and we just need to do our best to share the information and keep the decision makers also, let's say, that they know that why do we need it. That's maybe the best answer. And that's what we're thinking in DigiRail a lot.
Juha, you really touched on the right point there, because one of the things with big data approach is that you don't know what you don't yet know, or you don't know what you will want to know when you know something. So we start with a clue, and then we have a hunch, and we go off in our direction, then we try and make something great. But in order to make sure that the people who invest in that right from the beginning understand how great it could be, how do we tackle that, Matt?
Yeah, it is a great question, a great tee up. The first and fundamental piece you have to have is trust in the data set. And trust in the data set comes from a couple different places. It comes from people being able to know the path that it took, and also know that if there's a problem in the data, you can go in and fix it. There's a way to correct, or at least identify that you can identify this is good data and this is not good data. That's kind of fundamental. Then the analytics build on that, right? So fundamentally, the issue is about making the data reflect reality. And of course, the problem with that, digital twin is a great concept for driving that reflection of reality, right? It's a digital shadow of what's actually happening in the real world. The trouble is that reality is a perception, right? There is no absolute definitive reality. And so as people interact with the system, what you really have is a collective reality or perception of what is actually happening. And that's why the whole stakeholder thing is really key, because it's really a collective vision. What is your operating model by which you build this digital twin, by which you operate? Because that's really, although it's in a puristic sense, it's great to think that it's engineering, right? It's hard science. It isn't really. It's a lot of complicated things and a lot of what people want to get out of it. So the idea that you interact with this thing, the idea that people, when they identify something, there's a place and a process to capture that knowledge and a place to go create this unified vision of what reality is for the organization is really the key point. And without that, if you don't have a way to capture it, it becomes really elusive, right? And knowledge comes in lots of different ways, right? It comes in different kinds of analytics. It comes in just comments and notations and documents. I mean, so how do I integrate all these kinds of knowledge and bake that into a unified system that everybody can leverage, right? It's a complex problem for sure.
Thanks for that answer, Matt. Thanks for the answer. I think that sheds more light on it. And I think everybody here faces this as a daily challenge. And I'd like to hear from David briefly before we wrap it up, because I know that this is part of your business too.
In terms of data, I mean, if you don't know what you want to do with the data, it doesn't mean anything. You can collect a lot of data that are useless. So it's really a kind of collaboration between the railway experts that are either in the offices and doing analytics, or in the field, and what you want to do with the data. Do you want to improve maintenance? Do you want to monitor something which was not monitored before? You want to save time, improve safety of the workers, and so Without that, you can do a lot of data collection, a lot of analytics, and it's kind of and it's good for engineers, for us. But if you don't know why you do that, I would say there is no use of no use of that. The second thing is that if you know what kind of data you want, collect more than needed. And then you have two paths. The path for the initial target, and another path is, I don't know why it's like this, but it's like this. And that's a part of big data analysis. And say, okay, we have discovered that combining that, and that means we have this effect. And we are able to treat this effect. But first, for us at least, is that seeing who you help, why you help, and then you will discover something else that will benefit to another part of the business.
Thanks, David, for that answer. I see certainly Isabel was nodding. I think a few nods there from Juha as well. I guess there's some different sort of objectives or situations that you guys are facing, because you all have big projects, and some of them are kind of greenfield or new projects, and you can implement new things there, or you could actually adopt things that have been tested by other people. But it's an interesting dilemma, because there's almost a contradiction in David's answer. I don't want to say you're contradicting yourself, David, but there's two sides. If you don't know which data you need to begin with, and then sort of make sure that you do, but you still don't, maybe you don't. And then the next side is make sure that you've got more data than you probably need, because that's how big data works. So
yes, but once you have chosen the initial set of data, don't hesitate to enrich it by some other data.
I understand.
The core set, I would say, is essential.
Exactly. So it's about aggregating data with other sources of data to get more perspective, more context, and be able to make better decisions and understand. Okay, so necessity is the mother of innovation. We started with that. I think that we've had a year full of necessity, and we're looking forward to the next years of innovation that are going to come from this brutal 2020. I think that one of the things that comes across very strongly to me is that the motivation, and you can see we've got several hundred people attending this webinar today. We have a fantastic panel discussion today. I think everyone would agree. There's a great motivation to work together. There's a great motivation to improve things. We talk about rail infrastructure that's 150 years old. I think we all agree it's about time that we spend some more money on this infrastructure. But let's do it right for the next 150 years is probably the sort of the wrap up. I guess we finish it there. I'd like to say thank you to everybody. Johan, we can't see you, but we appreciate your attendance and involvement. Thanks again to Matt. Always bringing some very insightful things from your experience and organisation, and maybe a slightly Silicon Valley approach as well, with you being over the other side of the Atlantic. Obviously, Isabel, Johan, and Juha, I wish you all the best of luck with your projects. They're huge. There's lots of risk. Lots of things can go very right as well, and it's going to be a really great impact on your own countries, I'm sure. And David, again, thanks for joining us and sharing your insights. It's fantastic to see the new developments since last time, and I think this, for example, the ice rail, the frozen rails example that you used is probably relevant to all of these regions that we've been talking about today. So I'd like to wrap it up and say thank you ever so much to everybody. I look forward to seeing you all again soon, and to be back with some more events from Road Time Media and the rise of IoT and big data in rail. So have a great evening, everybody. Take care.
Thank you all.
Thank you very much.
Thank you. Bye, everyone. Bye.